let's talk about critical points, not just stationary points, any of these key critical points. Critical points occur when the derivative is 0, so all right, we've got our stationary point, or is actually undefined. That can create some interesting things as well. Well, simply look at a picture to point out what we got. Here's it looks like a cubic. We have maximum turning points, that would be when the derivative is 0. We have minimum turning points, again, that is when the derivative is equal to 0. They are critical points, although I suppose we have a better name for those ones, we call them stationary points. The other type of stationary point we tend to see is one like that, where at that point we have a horizontal point of inflection. The right hand side here, the sideways parabola I've drawn in. At that point, we would get a vertical tangent. So if you think about it, vertical tangent means its slope would be undefined, because we're going to have a slope of infinity, if you like, because it's straight up and down. So therefore, if I've got a derivative being undefined, it may be, it might not be, it may be a vertical tangent. Why might it not be? Well, it might also be a point of discontinuity, because if that value wasn't in the domain originally, then of course it's highly likely that the derivative is going to be undefined as well. So it might be that situation. Then we have unusual looking things like this. That's what we call a cusp. At that point it's undefined as well, because it's not smooth continuous. You might recall we said in order for a curve to be differentiable, it had to be smooth continuous. Yes, it's continuous, but it's certainly not smooth. If I was to approach that particular point from the left-hand side, I would have a negative slope, but if I was to approach it from the right-hand side, I'd get a positive slope. And it needs to be the same to be smooth continuous. So that's our cusp. It's undefined. It is a minimum point. It's just not a minimum. Could you call it a turning point? I suppose you could call it a turning point. It does go back the other way, but it's not that classic turning point that we call. So there's our cusp. An absolute value curve would also have a nice sharp point like that. Though we don't tend to call those ones cusps. Cusps tend to be the ones where they're curved like that. That shall do it.